Hi everyone, in today's lesson we're going to review motion of a line. I really need to review the components of motion of a line before I can connect what we did with differential equations to our next topic. So I'd like us to recall the relationships between S of t, V of t, and A of t. Recall where the particle is at rest and where the particle changes direction and moves from left to right. So let's talk about the relationship. So the first relationship that we need to discuss is that S of t is also referred to as X of t sometimes, which is our standard position. Or we could say the original position of the line. Then we have V of t, which is our velocity function, which is the derivative of X of t. Okay, so I'm going to use X of t instead of S of t. Then we have A of t, which is our acceleration function, which is the second derivative of S of t, or X of t. So let's start with an example. So we'll say example number 1. So I'm going to define the standard position X of t as x to the third plus 3x squared minus 7x plus 1. And I'd like you to find S of t. V of t. So V of t, we know, is the derivative of X of t. So to find the derivative, we take the power, drop it in front, and decrease the power by 1. Same thing, multiply the 3 and the 2, make that 6, and drop the power down by 1. The derivative of 7x is just 7, and the derivative of a constant is 0. So that's my V of t function. Then I could ask you to find A of t. So A of t is the second derivative, or the derivative of V of t. So bring this, multiply them together. 6x, drop the power down by 1, and the derivative of 6x is just 6. So the idea between these three things is that A of t is the derivative of V of t, which is the second derivative, or V of t is the first derivative of X of t. And then I could ask you to find some things like, if I said find V of 2, that means find the velocity when x is equal to 2, and all you would do is plug that into my V of t function. If I asked you to find A of 7, you would then plug that into the value for t, and that would be it. I'm not going to actually do those, but that's the relationship. That's the first goal for today. What's the relationship between A of t, V of t, and X of t? So the second one is I want to do where is the particle at rest and where the particle changes direction and moves left and right. And I'm actually going to go through a full example with this one. Okay, so our second example is, we'll call this X of t, or our standard position function, is t to the third minus 30t squared plus 225t. And the question is asking you to find where the particle is at rest where the particle changes direction and where the particle moves left and right. And this is all for time is greater than or equal to 0. So basically where time begins. So to find where the particle is at rest, we need to recall that where the particle is at rest is where V of t is equal to 0. So I'm going to do that over here. And first we need to find V of t. So V of t, we know, is the derivative of X of t. So I want to take the derivative of this. So I'm just going to quickly do that because this should be a review. You should get 3t squared minus 60t plus 225. And to find where it's at rest, we're going to set V of t equal to 0. So 3t squared minus 60t plus 225, and we're going to factor. So the factoring method that I'm going to use here is I'm going to try to take out a GCF of 3 first. So what I'd like you to do is divide 225 by 3 and see how many times it goes evenly into it, and hit resume when you're ready to continue. So we get 3t squared minus 20t plus 75. And we're going to continue to factor this trinomial on the inside. What numbers add to negative 20 that multiply to 75? So at this point, you can go to your calculators and type in y equals 75 divided by x and take a look at your table of values. And you should see 1 and 75, 3 and 25, 5 and 15, and maybe some other ones. But the one I want to focus my attention on is 5 and 15, because 5 plus 15 is 20. So I know that to multiply to a positive 75, I could also have 2 negatives. So I can make this 3 in front, t minus 5, and t minus 15. So I get t is equal to 5 and t is equal to 15. So these are the spots where the particle is at rest. Now to answer the second part, where does it change direction and where does it move left and right? Well, we're going to have to do a little bit more work. So we have to make a v of t number line. And on the number line, we're going to put 5 and 15. Those are the times where it's at rest. And we're going to see where it's positive or negative. So I'm going to select a number to the left of negative of 5, but don't go past 0. So it may not be a bad idea if we go ahead and put 0 here. So pick a number between 0 and 5, and we're going to test it. So I'm going to pick 2. I'm going to put it here in yellow. And between 5 and 10, 5 and 15, I'll choose 10. And then a number after 15, I'll choose 20. So now what we're going to do is we're going to go back to our calculators, and we're going to put in into our y equals, we're going to put in this v of t function. So 3t squared minus 60t plus 225. And we're going to plug in the values for x, 2, 10, and 20. But we don't have to plug it in. We can just go ahead and type it into the y equals and look at the table of values. So take a minute, pause the video, put this into your y equals, and look at your table of values, and then more specifically, look at what happens at 2, at 10, and at 20. And then hit resume for the answer. So at 20, I see 225. At 10, I see negative 75, and at 2, I see 117. So what that tells me is that since this 117 is positive, and that was when x was 2, that means this interval right here has to be positive. So I can go ahead and put a little plus sign here. This whole interval would be positive. And if we look here, 10 is negative 75, and 20 is positive. So to answer the question over here where it says, where does the particle change direction? Well, it changes direction when it moves from any positive to negative or any negative to positive. So at 5 and at 15, it changes direction. So it's at rest at those spots, and then that's where it's changing from positive to negative. It's going to be quick, like it's a quick change. It's not, something that is going to be resting for a while. And then the left and the right is just based off of these signs. So it's left when it's negative, and it's right when it's positive. So we are moving left from 5 to 15. So I'm going to write that down. So left is from 5 to 15, and we always use these soft brackets. And it moves right when it's positive. So from 0 to 5 and from 15 to infinity. Again, always using soft brackets. That's when it moves left, that's when it moves right, and it changes direction at time equals 5 and at time is equal to 15. And that's when it's also at rest, at 5 and 15. Okay, so I'd like to just quickly do one more problem. And so let's label this problem number 3, and we'll say the standard position x of t is negative t to the third plus 4t squared plus 60t for when time is greater than or equal to 0. And same conditions as before, I'd like to find where the function is at rest and where it moves right and left and changes direction. So the first thing we need to do is find our v of t function. So v of t is our derivative, so negative 3t squared plus 8t plus 60. Now, I wanted to go over this example because this is a problem where the leading coefficient is a negative 3. So if you don't like factoring by the AC method or guess and test, I think what would be helpful at this point would be if you use the quadratic formula instead. All right, so whichever way you want to do it, take a minute, try it on your own, and then hit resume to get the answer. Okay, so a couple things that I'd like to point out is that I don't like factoring when I have a negative in front. So I took out a negative 1, and then I factored by guess and test. And these were the results that I got. Now, you should be noticing that negative 10/3 doesn't really fall into our interval of time is greater than 0. So for this particular situation, we need to reject this because negative 10/3 is not in the interval, so not equal to, we could just say, greater than or equal to 0, right? It's not in that interval, so we have to reject it. So this right here, time equals 6, is really the only part where v of t is equal to 0 in our given interval. So we have to decide now where is this particle moving right and where is it moving left. So again, we need our v of t number line. We can go ahead and put 0 on there and 6. So take a couple of minutes, plug this into your y equals, and do a few test values. So I don't know, I'm going to pick 2 and 10. Feel free to choose whatever you'd like, and hit resume when you're ready for the answer. Okay, so I got these values when I plugged this v of t into the y equals. I got positive and negative. So it tells me that I'm moving right here and I'm moving left here. So that's it. So the particle is moving right from 0 to 6, and the particle is moving left from 6 to infinity. And that's really it. I mean, you could also say that at 6, it changes direction. And it changes direction there because I went from positive to negative. So really the whole point of this example was to show you this, show you the rejection, and show you either guess and test or the quadratic formula. If you're having any trouble with any of those parts, feel free to reach out and I'd be happy to help. Okay, have a good day.